Hey guys, how's it going? I'm going to go over how to solve a circuit problem with two resistors in parallel. Like the previous video on series circuits, I'm assuming you already know Ohm's law and concepts of a parallel circuit, including the equation on how to calculate the total resistance, but I will review them here as well. I'm going to solve every component of Ohm's law, voltage, current, and resistance in a simplified method. Okay, so let's get started by drawing a parallel circuit. I'm going to give it 9 volts. The first resistor is going to have a resistance of 2 ohms. The second resistor will have a resistance of 6 ohms. So this is our circuit drawing, and I'm going to put it all the way in the corner right here. And then I'm going to draw a table like we did in the series video so we can calculate the voltage and other components of a circuit. So voltage is in units of volts. Current is in units of amps, and also resistance will be in units of ohms. We're going to calculate these components at resistor 1, resistor 2, and for the whole circuit, which we'll just say T for total. So if you look at your circuit diagram, you can see that the resistors have values of 2 and 6 ohms. So we'll put that in. Unlike this series video, you can't just add up the resistors to get the total resistance, but we can still figure out the total resistance by using an equation. So what we can do instead is calculate the total resistance by using the fact that 1 over the total resistance is equal to the sum of 1 over all the resistors. So specifically here, it'd be 1 over R1 plus 1 over R2. So then 1 over the total resistance is going to equal 1 over 2 plus 1 over 6, because 2 and 6 were the values of the resistors that we have. In order to add fractions, you need to find a common denominator. In this case, we can use 6 as our common denominator by multiplying the first term by 3 over 3, so that it also has a denominator of 6. So we have 1 over the total resistance is equal to 3 over 6 plus 1 over 6. So now we have 1 over RT is equal to 4 over 6. If you leave your answer like this, either you'll get 0 credit or partial credit, because we don't actually want 1 over the total resistance. What we want is the total resistance. So what you can do is, knowing the trick of if you flip a fraction on one side of an equation, you can flip it on the other side as well. So then we have total resistance on top, which is what we want. This equals 6 over 4. 6 over 4 reduces to 3 over 2. And then in decimal form, this is just 1.5 with units of ohms for resistance. So now we can fill out our table and say that the total resistance is 1.5. If you look at the circuit diagram, you also know that the total voltage drop across the whole circuit is 9 volts. So let's go ahead and fill that out as well. So we know that the total voltage drop is 9. Again, if you have 2 components out of the 3 in Ohm's law, you can solve for the third one. Specifically here, it's going to be the total current in the whole circuit. So let's go ahead and calculate IT, or the total current. So I'm going to zoom this out. And then we can say that total current is going to be calculated using Ohm's law, which is V equals IR, but we're going to do it specifically for the total circuit. We know that the voltage across the whole circuit is 9. We're still trying to find total current, and then the total resistance, which we just calculated, was 1.5. So then divide each side by 1.5 to get total current by itself. 9 divided by 1.5 is 6, so we have 6 amps as your total current. And then we can fill that out on the table as well. So we have 6 right here. At this point, it looks like we don't know a lot, but we do. So in a parallel circuit, the current splits, and when it splits, it doesn't necessarily split evenly unless the resistors are the same. So in this case, the current is different through R1 and R2. However, you should know that in a parallel circuit, the voltage drop is always the same across each resistor and for the whole circuit. So we know that the voltage drop across R1 and R2 will be 9 volts each. And again, if you look at this table, you can see that you know 2 components out of the 3 for Ohm's law. Specifically here, I'll be calculating the current through R1 and R2. So let's go ahead and calculate the current through resistor 1 first. So I'm going to move this out here. So we have at resistor 1, we can use V equals IR again. But specifically resistor 1, we know that the voltage drop across the resistor is 9 volts. We're calculating the current through resistor 1, and we know that resistor 1 had a value of 2 ohms. So then go ahead and divide each side by 2, and then 9 over 2, which is equal to 4.5, is going to equal your current through resistor 1, and the units are going to be amps. So that we have that part right there, so we can fill out this as 4.5. Okay, so to calculate the current through resistor 2, you have a couple options. I'm going to do it the way we've been doing it in terms of using Ohm's law, and then I'll show you a different way as well. So let's calculate the current through resistor 2. So we have R2, V equals IR. We're going to calculate it specifically through resistor 2. So we know that the voltage was still 9. We're trying to calculate the current, and the resistance of R2 was 6 ohms. So divide each side by 6. So 9 over 6 is actually equal to 3 over 2. And that will equal your current at R2. Also, 3 over 2 is actually 1.5. So we have 1.5 amps as I2. So this is option 1. Another way to calculate the current through resistor 2 is to remember that the current through each resistor in a parallel circuit has to add up to the total current of the whole circuit. So I1 plus I2 needs to equal I total. Recall that the first current that we calculated through R1 was 4.5, and say that we don't know I2, but we also calculated that the total current through the circuit was 6 amps. So then if you subtract each side by 4.5, you'll end up getting that I2 is equal to 1.5 amps. And if you notice, this is exactly the same answer. I personally prefer this method, but it doesn't really matter how you do it. These are just options that you have. So now we can fill out the table and put in 1.5. If you notice, 4.5 plus 1.5 equals 6. And there we have it. Thank you for watching this video. Feel free to comment below.